Hi everyone. In earlier videos, we discussed about the determination of ultimate flexure strength of rectangular section and T sections in which depth of neutral axis falls within the depth of the flange. But in this video, we will discuss and determine the ultimate flexure strength of the T section where the neutral axis falls outside the flange, that is depth of neutral axis is greater than depth of the flange. In this case, there will be an additional stress block diagram. In earlier case, we discussed about this stress block diagram where the outermost compression fiber is having the stress of 0.45 FCK and the total compressive force will act at distance of 0.42 XU and the total tensile force is FPS into area of precessing steel. Now, this is the new stress block diagram. Here also, the outermost compression fiber is having the stress of 0.45 FCK. But here, the compression side, we have a rectangular portion. That's why this stress, this total compressive stress 0.45 FCK into B minus BW into DF. This is the total compressive force. This total compressive force will act at a distance of DF by 2 or 0.5 DF. Then the lever arm will be, D minus 0.5 DF. Earlier this value is D minus 0.45 XU, right? XU. But in new stress block diagram, the lever arm is D minus 0.5 depth of the flange. Right? Now we need to remember this equation and this lever arm equation. Right? Then the new moment of resistance of the section or ultimate flexure strength of the section can be calculated. The moment of resistance of this stress block diagram plus moment of resistance of this stress block diagram. Right? Here, this total compressive force here the moment of resistance from this stress block diagram will be FPS into area of precessing steel into lever arm D minus 0.42 XU, means this value multiplied by lever arm plus this force 0.45 FCK into B minus BW into DF into this value, that is this one. This is the new equation to determine ultimate moment of resistance or ultimate flexure strength of the T section in which the depth of neutral axis is greater than depth of the flange. Right? Here, see, we need to determine this FPS value. this FPS value. This FPS value can be determined as discussed in earlier problem. Same, from table 11 we can determine this FPS value and depth of neutral axis from table 11 using the effective reinforcement ratio. Effective reinforcement ratio means this term. This is FP only. This is actually, this is not FP. This is FPB, right? This is FPB. This FPB value we need to determine from table 11 of effective reinforcement ratio using APS. This is FP means characteristic tensile strength of the steel. Characteristic tensile strength of the steel. This is characteristic compressive strength of the concrete. With the help of this term, we can determine the FPB by 0.87 Fi value. Once we know this value, from here we can determine the FPB value. This is what we need to determine, right? And from the same table, we can also determine the XU by D value. Once we know the FPB and XU value, simply we can substitute FPB value and XU value, then we can able to determine the moment of resistance, right? In next video we will solve a problem on this topic. Okay, thank you.